Hey everyone, I'm Daniel. As Stasia mentioned, I'm a solutions engineer on the TeamCity team, and TeamCity is JetBrains' CI/CD solution. So I'm showing here today our TeamCity Cloud offering. So I'm logged into a TeamCity Cloud server, and this has a couple of projects on here. So I have a Unity project, which is called JetBrains Token Chaser. And this consists of a few different parts of a build pipeline, including some tests, building for different platforms, and also deploying to different platforms, including deploying the iOS version of the game to Apple's TestWhite service, and deploying a WebGL version of the game to a Amazon S3 bucket, which is running as a website. So if I click this shortcut here, I can see a running version of the game, and I've got this character that can run through this world and collect these JetBrains tokens. Unfortunately, these aren't redeemable for any cash, but that's the web version of the game. And if I switch over to my phone, I have the same game running on my phone here, so I can do the same thing. So before I go into too much detail about how TeamCity is configured, what I want to do is make a change to my game because I want to show what happens when I commit a change and have TeamCity respond to that commit. So one of the things I like to do as part of this demo is go into my Unity project and just change the color scheme. So if I change it from the current blue color to something else, maybe go for a purple color to match the event color scheme. Yep, so we'll save that. And over in Rider, I can come in and commit that change to the scene file. I'll say new color scheme for game dev day, and we'll commit and push that. So over in TeamCity, this project for JetBrains Token Chaser, this is configured to point to the GitHub repository here. So this is where my Unity game is stored. So whenever a commit is made to that repository, TeamCity will immediately respond because I've set up a GitHub webhook. And hovering over any of the build configurations in my project here, you can see a summary of the commits. And if I click on the commit message, I can see the actual files that were changed. If those were text-based files, I can use the built-in diff viewer to see the before and after. And you can see that the build is immediately running. And for this, I have a bunch of tests executing. So first of all, I am executing some Unity edit mode tests, and you can actually see that a few of these tests are running concurrently. So if I go to the end of my project, I can show you the build pipeline. So in TeamCity, we call build pipelines build chains, but they're essentially the same thing. And this is a great way to visualize the pipeline for your project. And based on the dependencies of each part of your project here, TeamCity figures out which parts of your project can run in parallel. So because all of the tests that are being executed have no dependency on each other, TeamCity knows that it can run all of those jobs in parallel. And another nice thing, I'm also making use of a parallel tests feature for some .NET shared module tests. And this allows TeamCity to split a large batch of tests across multiple build runners or build agents. I'm then building the game for a few different platforms. And again, because those don't have dependencies on each other, TeamCity is able to run each of those jobs in parallel across different machines. And the way TeamCity runs the builds, so we have the server that we're looking at here. You then have one or more build agents that are connected to this server, and that one of those agents will take a job from TeamCity, run through it, and pass back the log file and any artifacts back to the server. In the example today, I'm using persistent agents that are running on AWS EC2, but TeamCity also supports what we call cloud profiles. So if I go over to my project and look at the cloud profile screen, this is where you can define your own custom cloud provider, for example, EC2. And this will enable TeamCity to spin up agents running under your AWS account, and it can resume and suspend instances as and when they're needed. It can also create a new instance from a AMI. So this is a great way to provision agents as and when they're needed, rather than having them running 24/7. So back to my project here, if we look under here at the tests, we can see that the tests have finished executing. And the way that I'm executing these tests, if we go down and look at the build steps, when you add a build step, there are a number of types of out-of-the-box runners that we provide our users. So if you're using .NET, there's a .NET runner. If you're using Node.js, there's a Node.js runner. But more importantly, for game dev, there is a Unity build runner built into TeamCity. And just a few weeks ago, we actually released a Unreal Engine build runner for TeamCity, and this is available as a JetBrains plugin. And this makes it much easier to configure your Unreal Engine builds and your Unity builds through TeamCity. So jumping back to the build step for my tests, all I had to do here is define the working directory for my Unity project. So looking at the repo, my Unity project is within the Unity project subfolder. So I've set that as the working directory. And then scrolling down, I've checked the option here to run tests from the project. And then the test platform, I can choose the type of tests I want to run. And over in Rider, I have a bunch of tests under the edit mode tests folder, and these will be executed by TeamCity. And then scrolling down for the Unity version, you can set the detection mode to auto. So the installation directory will be automatically located on the build agent. And then if there's a particular Unity version you wish to use, you can define that version here. So jumping back to the test results, whenever tests are executed by TeamCity, the results will be automatically passed. So there will be a tests tab, and you'll see all of the test results inside of the user interface. You can also drill down into each of these tests and see the time that it's taken to execute that test over all of the previous runs. And you can also see whether it was successful or failed over any of the previous runs. So that's the testing. Then over on the build side of things, we can see that all of the platform builds have finished. So if I hover over the Android build, for example, we can see that there is a game android.zip. And if we expand this in the TeamCity UI, you can see the APK file inside of that zip. The iOS one typically takes the longest, and this is a kind of two-stage build because the way I'm executing a iOS build is I first of all generate the Xcode project, and that could happen on a Linux or a Windows machine. And if your Mac OS resources are constrained or you don't have too many Mac OS resources, this is a great way to cut down the build time on those machines, because the generation of the Xcode project can be done on a lower cost machine. And then when you need to sign the game, so generate the IPA and sign it, that can run on a Mac OS environment, which we're doing here. And I'm actually making use of Fastlane for this build, and we'll look at that in a bit more detail shortly. The WebGL game has also finished building, and we can see the zip file for the game. And then under the deployment jobs, most of these have finished, including the WebGL version of the game, so we'll come back to this shortly. But looking at the build iOS and how this is configured, so under the build steps, there are a few different build steps here, and the first build step will grab a few secret values from AWS Secrets Manager. So because I have the AWS CLI installed on my build agent, I can make use of the AWS command and retrieve the different secret values, which would be my private key, the sign-in certificate, provisioning profile, all of those kinds of things you don't want to store directly inside of your repository. And to make it easier to authenticate to AWS, one of the great things that we include in TeamCity is the ability to define various connections to third-party services. So under the connections here, I have a connection defined for Amazon, so AWS. So we include this as a out-of-the-box connection option. And what this enables you to do is come in and choose the region you wish to use, the authentication type you wish to use. And when you are using access keys, those access keys are never passed down to the individual build agents. Rather, TeamCity can issue temporary credentials only on request, and those are time limited. And it's much more secure issuing those temporary credentials to the build runners, and they're invalidated after a certain period of time. So jumping back to my build, that's the first build step for generating the iOS build. I'm then downloading the latest Apple CA certificates from the Apple website. And then the third build step runs a Fastlane build, as well as getting a few more secret values from AWS Secrets Manager. And what I'm doing down here is executing Fastlane and passing in the lane name, so the build IPA. And if I jump over to my repository, there is a Fastlane folder, and this contains my fast file with my various definitions, and you can see the build IPA here. So this is where it's going to create the keychain, import all of the certificates, and then scrolling down a bit further, we can see it updating the code sign-in settings, and finally building the app and also signing it. So that's how the game is being built by TeamCity. And then if we go down to the deployment, we'll look at how the deployments happen. So first of all, the web version of the game, so the WebGL version, the way that this is deployed is we deploy the web version of the game to a S3 bucket, and that's running as a website. So I have a very simple command line build step here that will sync the copy of the game folder to this S3 bucket. And how we get the game folder within the deployment is through the dependencies screen. And in TeamCity, there are two types of dependencies. So the first one is called snapshot dependencies, and this is what gives us our build chain. So by saying that the deployment depends on the build WebGL, that creates a direct linkage between those two jobs, and that then forms part of the overall build chain. And then scrolling down a bit further, we've got artifact dependencies. And this is important because when you run a build in TeamCity, there's a chance that each part of your build chain won't necessarily run on the same build machine. So you need a way to pass build artifacts through your build chain, and that's done through artifact dependencies. So I've configured this as follows. So I've added a dependency on build WebGL. Once you've selected a job, you can click on the icon here and see a list of the recent artifacts that were attached to the most recent build. So you can click on this and it will add the file to the list of file names here. So because it's a zip file, I've used this syntax to automatically extract the contents of the zip to this folder, so the game folder. And that's how the build step here has a reference to that WebGL game. And then I've got a couple more AWS S3 commands that just fix the encoding for some of the gzip files. And that's pretty much all that's needed to deploy a web version of the game. So quite simple, really. And then back under deployment, we're looking at how the iOS deployment is executed, because this is actually deployed to Apple's TestFlight service. So under the build steps, the first build step is to get the Apple App Store Connect API key. And again, this is stored in AWS Secrets Manager. So I'm using this syntax to get the value and make it available to the build agent. And then the second build step, this is using Fastlane again to use the deploy to test flight lane. So if we go to my fast file, you can see the deploy to test flight. We generate the API key, and then we use the upload to test flight and specify the IPA file and any of the other settings. And one of the things I'm doing here is in earlier on in my build chain, I actually generated a change log, and this is based on the commit messages that are sent with all of the commits. So all of those commit messages are included in a text file. So when the app or when the game is deployed to test flight, we will see a summary of all of the commit messages. So the user that's testing the game on the device can see a list of all of the changes from those commits. So if we go back to the build configuration for the deployment, we can see that the deployment is running through at the moment. The time it takes for this to run can vary. It does give you an estimate for how long it normally takes to run this job. We're slightly over time here, but we'll leave that running. But the WebGL version of the game has finished deploying. So if we click the link here, we can see hopefully the new purple version of the game, which is great. And I've just lost. Okay, so over on the deployment for iOS test flight, this is still running, but we will let that run through for a bit longer. But this is showing a good example of how to build and deploy a game for Unity, but we also offer a similar build runner for Unreal Engine. So, oh, and just as I said that, the deployment to iOS has succeeded. So if I go over to my device and bring up the test flight and just click the update button, this will download the new version of the game, and we can actually test that live here. We'll leave that to run for a minute or two. While that's downloading, we'll look at the Unreal Engine version of the game we've got here. So how you can configure a Unreal project in TeamCity is very similar. So under the configuration, we have a build step for Unreal Engine. And in here, this contains options specific for the Unreal Engine games. So you can choose the tool you want to use, whether it's UAT or whether it's editor. And if it's editor, whether you want to run the automation tests. And if you do, you can choose the project and the tests that you want to execute. So if we look at a already finished build, we can come into here, and similar to the Unity project, we have the test results automatically passed by TeamCity. And then this game is being built for both Linux and Windows. And there are two different ways that this game is being built. So in the Unreal Engine build step, for this game, I'm using build graphs. So we do have basic build graph support in the Unreal Engine plugin. So you can point it to your build graph file and define any particular options. And this will generate the Linux version of the game. And very similar, we also have a Windows build. And if we look at the configuration for this one, we're making use of build cook run. So I've just defined the uproject file and told it which platforms to build for, so Win64. And then under the general settings, this is where I've defined the build artifacts. So I'm grabbing the contents of the Win64 folder, and that's stored as a build artifact over in TeamCity. So at a high level, that's pretty much how Unreal projects are configured in TeamCity. So very straightforward. You don't have to figure out all of the command line options to execute. An important note is TeamCity does provide out-of-the-box support for Perforce. So this game is actually hosted on a Perforce server. So if we look at the VCS routes, we can see that this is a Perforce type VCS route. So this is also supported along with Git. So let me check if the game has finished downloading on my phone. Oh, it's downloading at the moment. That's fine. Let me jump back to the project screen and just check I haven't missed anything. But yeah, I think that's pretty much everything. So are there any questions in the chat at all?
Yeah, so like there is actually some nice discussion ongoing in the chat. We're trying to help with it together with Matt, but maybe like, yeah, you can also address it. So there are like some discussions about what actually is needed to have all this magic regarding the plugins. So what the people need to install to get all of this in terms of Unity, Unreal, and also maybe like because you have Writer, maybe there is also something needed for integration with Writer. So if you can just briefly describe this setup required
Sure.
for all this
Yeah.
fantastic magic you are showing.
Yeah, so one of the easiest ways to get started with TeamCity and Unity or Unreal Engine is to sign up for TeamCity Cloud. So we do actually have a free 14-day trial for TeamCity Cloud. We bundle the Unity build runner as part of TeamCity Cloud, so there's nothing extra that you need to request as part of your evaluation. If you wish to try Unreal Engine, then that's something we can make available to you on request. But yeah, there's no additional plugins required or nothing extra needed to set up. Yeah.
No, sounds cool and quite smooth.
Yeah.
Yeah, awesome. Also, there was a question about the running engines locally on the user machine. Is it possible?
Yes, you can. So you can set up your own build machine as a build agent. And so we would classify that as a self-hosted build agent. So there's a TeamCity agent process that you can run on your local machine, and you can connect that to your TeamCity server as an agent. So that'd be quite useful for testing purposes if you just want to use your own agent to ensure that the TeamCity build will run through. Once you're satisfied it does, you could then set up proper agents that are hosted in the cloud that can be used for your repeatable builds. Yeah.
Okay, thank you. Thank you very much.
Sure.
Matt, do you see more stuff we haven't answered yet?
Well, I was wondering how you handled large assets, because obviously game dev requires assets which can get very large there. And if you've got big projects and things, how do you get that working with different agents?
Yeah, that's a good question. So there are a number of ways that you can handle large projects such as Unity. So because Unity does have a large number of assets or a large library folder, one of the easiest ways to handle that is through the use of persistent build agents. So agents that are used over and over again for the same builds. Those agents can either be resumed and suspended as and when the builds need to run, or alternatively, you can keep them running all the time, and then the build will just run on that same agent, and it has all of those dependencies and the library folder cached already. In TeamCity, we do also have a preview feature of that's called build caches, and this enables you to easily cache a subset of files or folders on the build agent and store them on the server for subsequent distribution to another agent. So that's another option. And then a final option I can think of is we have an upcoming feature called AWS Image Builder, and this will enable TeamCity to actually generate a new EC2 AMI, and this can help you to bundle a copy of the repository inside of the machine image, and you could run this on maybe a nightly basis, and you could also include the assets or any dependencies that need to be included, so they're kind of preloaded. Yeah.
Okay, that sounds good. Speaking of dependencies and things, the chains that you've got going on within the builds there, how do you set those up?
Yeah, so
you could quickly demonstrate.
Yeah, of course. Yeah. So the build chain, which I showed earlier. So if I go into here and show the build chain view, this shows the overall dependency chain. So you can see how each of the jobs depends on each other. How that is set up is done through the dependencies section under the configuration of each job. So for the deployment of iOS to test flight, this will depend on build iOS. So that sets up the build chain configuration. And then you also got the artifact dependencies for passing down artifacts through that chain. Yeah. And just before we handle any other questions, if there are any, the version of the game has actually just downloaded to my phone. So if I click on open, and you can see here under what to test, it's got the text from my commit message. So because I'm generating that changelog and including that as part of the game. The user that's testing this on the device has a list of all of the recent commits. So if I click next, we can then start testing the game, and we've got the nice purple version like before. Yeah.
Wow,
Nice.
looks
It's good
impressive.
to see it. And we do love purple as well. So this is
Exactly. That's right.
But a kind of a bit of a follow-on question from the dependencies there as well. Seeing as you're in the config of the project there, it's dealing with different environments. Question from the chat really. So if there are different branches which trigger a deploy in TeamCity, where can you handle sort of doing different things there with different environment variables, different setup, and different, how to handle doing different stuff with different branches?
Yeah, sure. So multiple branches are supported in TeamCity. So for this example, I'm just running everything against the main branch. But if I were handling commits from different branches in my repository, I would actually see a branch filter on this screen, and there would also be a branch next to each of the builds shown in the list here. Because I'm just working from the one branch, I don't see that option here. In terms of handling builds for different environments and different settings, in TeamCity, there is an option, or rather there's a screen to define different parameters. So under the parameters screen here, this is where you can define shared parameters that you want your builds to use. So rather than hard coding string values or hard coding passwords or access keys in your build scripts, you can define them here and set their type to password if they're sensitive values. Environment variables, these can be passed down to the build machines. So this is a good way of sharing environment variables across those machines. And lastly, if I go down to one of the jobs, for example, build and build iOS, if you wish to run this build on a particular type of agent, you can come to the agent requirements screen and choose a particular OS using one of the options here. For the demo today, I've just set it to a particular build agent name, and this is how you can set the requirements for how and where the build is executed. Yeah. Oh, and one final thing I haven't touched on, the configuration I've shown here is actually done all through the user interface. So the demo today I've shown is UI based, but TeamCity also supports what we call configuration as code. So all of the configuration that you've seen in the UI can also be done through Kotlin DSL, and this will show you the equivalent configuration if you were to define this using Kotlin.
Yeah, that's really cool. I like the Kotlin example there as well, because you can commit that into your repository with your game as well. So you build config changes with your game itself, which is nice. We've still got a couple more questions. If you're happy to carry on there.
Yeah, of course.
We've got a question about licensing as well. So how do you handle the licensing for Unity? And also, as like a related question there is, if you're building games for Unity, doesn't each environment require a different license?
Yeah, so typically,
sorry.
Yeah, that's a good question. So typically each environment requires a license. So if you have a couple of options, you can either initialize the license on each of those build machines if they're persistent. Alternatively, TeamCity does include a build feature which is called Unity Build Settings, and this enables you to choose from a particular license type, whether it's Unity Plus or Pro or Unity Personal, and this can help you to automatically activate that license on the build agent, and then the license is revoked at the end of the build, which will free up that license for any other agents.
Yeah, just before we go to the next question, I just want to briefly engage, because we have also people on Cyprus who might also have their questions. So I would like just to engage, like if you're there, you have a nice host, so please just either share your questions in the YouTube chat, we'll handle that with all the others, or just share your questions with your host, and he will nicely pass it to us. So feel free to do that. No worries, we'll try to handle all of them. And while you're maybe collecting your questions, we'll go to the questions we have in the chat here. So there was a question about building to consoles. So if you do support building to consoles as well.
Yeah, so it depends on the environment that your Unity build is running within. The way that I'm executing the Unity builds in TeamCity, if I go over to my build here and we look at the WebGL build, for example, under the build step, the way that I'm executing the build is through the execute method here. So this is calling the WebGL game builder class and then the run build method. So over in my rider project, I have a WebGL game builder class, and this has a run build method, and this contains a config for the scenes that will be bundled, the output folder, and the build target. So the build target you could specify here. So as long as that target is supported by the environment that you're running Unity on, you should be able to build for any of those respective platforms.
Okay, thank you.
Sure.
Well, sounds good. Okay, Daniel, thank you very much for a fantastic session there. There's a lot of interesting things for people to go and try with their own builds there. And once again, thank you very much. I think we'll move on to our next speaker now. So
yeah, thank you, Daniel.
Thanks, Matt. Thanks, Anastasia. Have a great day, everyone.